Hello and welcome back. Thanks for staying with us. We are now coming to the 3 last slots of our third Industrial Ethernet week. And now I'm really happy because we will talk about connectors. All the applications we saw this morning need to somehow be connected, a PCB to a wire and then a wire to a PCB. And all this needs to be safe with even higher data rates from year to year. And now I'm then very happy to bring 3 global product management colleagues from myself on stage. I think we start with Marian, right? Welcome on stage.
Yes, hello and welcome everyone. So we are happy that you're back after the short break. So this part of the day is about high performance and innovative Ethernet PCB connectivity. And together with my colleagues Nikolaj, Ponomarjow and Maximilian Rohrer, we are presenting you 3 different trends of the industry. So the first one is the iX Industrial for fast and gigabit Ethernet, the M12 transformer solution with integrated magnetics, and last but not least, our T1 Industrial for single-pair Ethernet. And we will start with the iX Industrial, and for this, I will hand over to my colleague Max.
Thank you very much, Marian. And as well, a warm welcome from my side. I'm happy to be on your screen today. So when we speak about iX Industrial, let's step back to many years ago where RJ45 was invented. So this connector was invented for the telecommunication market, and it brings some negative effects with it. Huge size, limited robustness, limited performance. And this is why we said, okay, we want to have a real superhero, Captain iX Industrial, and this is how the development of iX Industrial begins. We standardized then the iX Industrial, and with this standard, we have millions of possible applications. So in this standard, there are 3 different types of connectors defined: type A, B, and C. So type A is for data transmission, type B is for signal or bus systems, and type C is as well for data transmission. And as you can see here on the screen, there are many different aspects, many different variations of sockets which the designer can use to implement the iX Industrial in the ideal form in his or her application. And the best thing is you have the security to use an international standardized interface. So it's an IEC standard, and we are as well in guidelines like GigE, like Profinet or CC-Link. And when we speak about these connectors, I want to mention 3 points: miniaturization, robustness, and performance. And I want to show you now a little bit more into detail what miniaturization means. So at first, we have a very nice picture here, RJ45 compared to iX Industrial. So we have a 70% reduced PCB space of the connector volume, and you save a lot of space onto the PCB with iX Industrial. A further big advantage due to the size reduction is the minimized mating phase. So we can achieve a 10 mm SMD pitch. Furthermore, we have a high package density, and in this way, we can even reach weight reduction in the applications in the end. And I want to show you some comparison. So what would you prefer? Would you prefer the RJ45s, which are showing above, or the iX Industrial? If you want to score it, 5 to 9, Captain iX wins with 4 points. And I will show you later on as well some application where you see it in real life. Next point is robustness, a very important point for designers. So we have THR shielding pins, which leads to very high retention force onto the PCB and give the reliability of iX Industrial. The next point is a robust connection between jack and then the 2 metal locking clips, which are integrated in the plug. So everything out of metal, no broken plastic clips or so on. Really everything was out of metal, so very robust here. Next point is high shock and vibration resistance. So due to the standard, which have minimized tolerances in the standard, we reach a really high shock and vibration resistance, as well as up to 5,000 mating cycles with iX Industrial. So a lot of more with compared to the RG45, which have, for example, today 750 mating cycles. So we heard miniaturization, robustness, and now we come to performance. So over the whole product line, we have a Cat 6a performance. So it is possible to transmit 10 gigabit Ethernet over all the iX Industrial. Furthermore, we have a continuous 360-degree shielding and a really robust cable attachment. And when we take a look in more detail, we see the concept here. So you take a look on the iX Industrial jack here, and you see that we have a shielding, the red line, the shielding shell between the two contact rows on the left, on the right side. Additional, we have two grounded contacts in the middle, and if you see it, it looks like an X, a little bit like M12X coded for perhaps, to separate the 4 signal pins or the 4 signal pairs. And so we reach even, or customers of ours reach even 2 times transmission of 100 megabit over one iX Industrial. And a further point in regards of the shielding is the grounding path. So we have a really grounding path from the cable over the connector to the socket until the PCB. So, and we don't have it only in IP20 versions, as you can see here. We have it as well as IP65, 67 version. We are in the industry, of course, we need as well higher protection degrees here with iX Industrial, and we have this as well in our portfolio. I will show you later some more examples, but for now I want to switch fastly to pre-link. Perhaps you know pre-link out of the connector world. It's a whole system, and we don't have only connectors. We have as well a solution which is going directly to the PCB. And there you can have a direct cable to board solution for your application. And it's well possible in IP20 and with a panel feed through as well possible in IP65, 67. And a big advantage is here on the one side, the robustness, the reliability of pre-link, of the pre-link system which you will use. And an additional aspect is the size. We have here a comparison between pre-link and RJ45, and you see you can reach about 50 to 60% place, which you can reduce. Yeah. So this is for now, and I want to go with you now to the next, to the table to show you the real applications here. So we have this patch panel, and you know the patch panel normally from the RJ45. And with an RJ45, you have 24 ports, and here with iX Industrial, we reach 36 ports, and you still see we have some space between, so it could be even closer together, but since we need to have a cabling at the end, we need some space as well here. So if we want to really reach the minimize of the pitch, we can take a look here on the demo box. So we have a 10 millimeter pitch here, which is really close together, and we can have a height over each other of 18 millimeters with our new IP20 push-pull. So it's possible with the latch to just unlock it, and you can have even a higher package density with this solution. And I talked as well about the pre-link solution. And the pre-link solution, you can see here how easy it is connected. So we switch to the kitchen cam, and this is the pre-link block. You just put it in, and it's fixed. And it's shock and vibration resistant. so you have always the perfect fit for your application. Furthermore, I showed you the IP65 word, right? And I bring there as well some applications with me or some examples. Here you see an example of mini push-pull. And you see how it was realized that we have on the back side the PCB and on the front side then the mini push-pull panel feed-throughs, which leads to the IP65-67 solution. And here I want to show you as well shortly the mini push-pull connector, which is made for harsh environments. And if we speak about harsh environments and about IP65-67 application, we need to speak about circular connectors. And here I want to hand over to Nico.
Thanks, Max.
Have fun. Goodbye.
Yeah. IP65-67 world is definitely typical for the circular connectors. And HARTIng is offering today a wide range of circular connectors, starting from the M5 size up to the M23 size. And the topic today is Ethernet. And there are specific Ethernet solutions in this range, and the smallest solution is the M8 decoded connector. And here you can see this product, so with the housing and just the PCB receptacle. This version is the 4-pole type for fast gigabit, fast Ethernet transmission. And the bigger brother or sister of this solution is the M12 decoded connector you can see here. And both versions are for fast Ethernet applications and can be used up to 100 megabits performance. And if that is not sufficient enough, the M12 range is also offering the so-called X-coded M12 solution, which is visible here. And this connector has 8 poles and a shielding cross in the mating phase and can be used for applications up to 10 gigabits per second. And when we are looking at these connectors, these are simple and standard connectors which you will find in the market. And HARTIng thought about innovative products in this range, and we created another solution in the M12 range, which is very innovative. And I would like to show you at the demonstrator here what is behind this idea and what is the product made of. So first of all, I would like to focus on the middle part of this demonstrator, which is showing the standard solution on the PCB. So this is the M12 X-coded connector, which we saw before. And here in this portion of the PCB, you see the additional components which are needed for every port in the application. And just in the session before the break, we've heard about the transformers and the purpose of the transformers, which are visible here. So this component here, and the transformers are needed to ensure the galvanic separation in the device and also improve the signal integrity or filter the signals in the application. And as you can see here, these components, like transistors and transformers, are separate components on the PCB. And this design is very typical today in applications and in devices. And what we thought about is the integration of these components into the M12 connector. And the idea is actually not very new, because the RJ45 connector, for example, or the jack, is state-of-the-art, which is integrating the transformers in just one component. And what HARTING did is we translated this idea to the M12 world and created the so-called M12 transformers. So we are talking about M12 connectors with integrated transformer unit within one part. And here in this demonstrator, you can see that this way, so these both ports are equivalent, but the version with the integrated transformers is reducing the needed space on the PCB, and we are talking about roughly about 30% of less space on the PCB and in the device. And we created in this range, and for this product family, we created several versions, which I would like to show you here once again. So there is a decoded straight version available for fast Ethernet applications in straight version and also in an angled version. Then there is a X-coded version as straight type and angled type available for applications up to 1 gig performance. And there's also a straight and angled version available of the X-coded type for gigabit Ethernet applications. So all these products are available today, and they use SMT termination technique for the soldering on the PCB, and they support power over Ethernet, and they are also designed for rush environments, like for the railway applications, and they withstand the shock and vibration requirements of these applications. And as I said before, due to this design, we are able to reduce the needed space on the PCB and in the device, and it's in line with the miniaturization trends, which are already mentioned by my colleagues like Max Rohrer. So hopefully these products are interesting also for some other applications, and now I would like to hand over to Marian again.
Thank you, Nico. So the last portion of this presentation is about the T1 industrial for single-pair Ethernet. So we've already heard a lot about the advantages of single-pair Ethernet this morning, how Ethernet data communication over only 2 wires works, and what applications and possibilities it offers. So, and in this last part, we want to focus more on the connectivity side and which products we as HARTING can offer. And we will start with a general overview about the technical performance of these connectors and the specification. And first of all, this connector is standardized according to the IEC 63171-6. So this IEC standard specifies the mating phase for single-pair Ether connectors for industrial purposes. So it also specifies the typical Ethernet interface design, where the device side is designed as a socket and the cable side as a pin version. So it's a very robust design. The whole connector is designed out of stainless steel shielding plates, which makes them very robust. So the standard also specifies different locking mechanisms and different form factors from IP20 up to M8 over M12s with 1,000 mating cycles plus for different IP ratings up to IP65, 67. We can cover a broad range of American wire gauges from 22 to 28. And we have an extended temperature range from -40 degrees up to +85. And the whole system is shock and vibration resistance according to the IEC 61373, which is the category 1B of the railway standards. And so the electrical performance of this connector is more or less very easy. It offers transmission speeds up to 10 gigabit per second. It has a voltage proof of 2.25 kilovolt from the data pins up to the shields. And it's 360 degrees shielded for an excellent EMC performance and signal integrity. And this is also the highest EMC class of the standards. So, and what makes this a high-performance connector for single Ethernet based on this technical specifications? So we have heard that for single Ethernet, a lot of various standards with different transmission speeds and transmission lengths are available, from 10 megabit up to 10 gigabit per second, and from 15 meter up to 1,000 meter. So, and this leads to a broad branch of different requirements for the connectivity. And when we think about connectivity, so you as the user don't want to care about which connector or which SPE standard you use in your device. So you want that everything works fine together. And that's what the goal when developing this connector from the very beginning, one fits all. So these connectors can be used for every single Ethernet standard which are available now today from 10 megabit up to 10 gigabit per second. So, and in addition to the technical specifications, one of the biggest advantages of using single Ethernet is the size advantage, the size reduction of this technology. Well, yes, it's obvious so that we have a big size reduction of this connector. So you can see that that on the picture on the top right-hand side is much smaller than the RT45 below. And we're talking about if you don't use Poodle, of space saving of about 15 up to 60%. And if you're using Poodle, it's approx 20% because you need a Poodle controller, so you need a bit more space on the PCB. But in addition to the size reduction of the connectivity, so we have also passive components on our PCB which are dependent on the number of conductors we are using, like magnetics or common mode chokes. And as we've heard, we also only use 2 conductors for single Ethernet. So we also need only 1 common mode choke and 1 magnetic, so 1 transformer, instead of 2 or 4, like we need for fast and gigabit Ethernet. And so the whole interface besides the connector can become significantly smaller. So, and that leads to also volume reduction of the connector. So you can see here a design study of a multi-port version for single Ethernet, and you see that we can reach a volume reduction of approx 50% compared to standard RJ45 connectors. So, and this in total leads to a significantly smaller devices, more sustainable devices with the same power compared to standard Ethernet we are using today. Or on the other hand, you can increase the packaging density on the devices. Another important point is for the circular connector range that the heights we are using today for the single Ethernet connectors are aligned with the heights of the M8 and M12 versions, D and X coded, which are available in the market today. So right now we are offering 2 different connector heights, 12.5 and 8 millimeter. So there is no standard in the market available for heights of circular connectors, but these 2 heights are very common and very often used by a lot of manufacturers in the market. And this is very important because when we think about, for example, about brownfield integration, where we mix up different data connectors for different protocols, like single Ethernet, fast or gigabit Ethernet, or for example, I/O connectors like M12A coded, or power connectors to power the device like M12L coded. So it's important that all these connectors are on the same PCB level to avoid any cracks or inconsistencies in the PCB design, like you can see it on this picture below, where we see a switch from the side with a power L connector, T1 connectors for single Ethernet, as well as M12 X-code connectors for gigabit Ethernet. And in addition to this technical specifications and advantages of single Ethernet, we already set up a big portfolio for single Ethernet connectors for IP20 applications, so standard IP20 connectors, field installable and overmolded patch cords, as well as vertical and angled device sides. In addition to the standardized connector, we also offer terminal blocks for low performance applications, or for, if you want to use very big conductor cross sections, bigger than AWG22, so 16 or 18, if you want to reach long transmission lengths and want to cover the voltage drop of the long cable lengths. And we offer a broad portfolio for IP65, IP67 connectors in different form factors for M12 and M8 with different locking mechanisms. Also the mini push-pull, the rectangular connector for single pair Ethernet with an additional quick lock mechanism, and as well as an M8 hybrid version with 2 separated power pins to transmit more power than Poodle offers right now. So with Poodle, you can transmit up to 50 watts up to the end device, and with the M8 hybrid, you can transmit 8 amps per contact, so that leads to 400 watts at least. And we also offer some active devices for single pair Ethernet. So we have IP30 switches with our Ethernet interfaces, as well as RJ45 interfaces to integrate that devices into the existing network infrastructure. They're working like media converters or gateways. And we also offer the first M12 switch. And all these switches are available for 100 megabit and 1000 base T1, so 1 gigabit per second transmission. And yes, that's it from us in this session of high performance and innovative Ethernet PCB connectivity. Thank you for your attention. And I guess it's your turn again.
It is. Thank you very much.
You're welcome.
Thank you, Marian. Thank you, Max. Thank you, Nico.